isotropic. Okay, generally crystals are segregated as isotropic and anisotropic. Isotropic means that they show same properties in all directions or same, and the property is not direction dependent. But in anisotropic crystals, the properties are different in different directions, and the physical properties like velocity, refractive index, they are different in different directions. So we now define the double diffraction something like this. When unpolarized light is incident on certain crystals, and that crystals we are calling anisotropic crystals. Because the incident light splits into two refracted rays. So therefore, if I take an anisotropic crystal, okay, if unpolarized light is incident on a crystal, within this crystal, the light is getting refracted into two parts. This is one part going in this direction, the other part may be going in this direction. Okay, that's what this says, anisotropic crystal. And okay, both these rays are plane polarized. Even the both refracted rays are plane polarized. One is having vibrations in this direction only, both are plane polarized, even though unpolarized light is incidented. One will have vibration like this, and the other will have vibrations only perpendicular to the plane. Okay, therefore we say that one of the refracting rays will have vibrations in the parallel direction, other will have in the perpendicular direction. We have perpendicular, so both are okay. These are unpolarized light, and these are plane polarized lights within the crystal, plane polar, because the crystal is a doubly refracting crystal, or we say anisotropic crystal. Within the crystal only, the rays will be incident ray will be divided into two parts, and beams instead of say two beams, and both these are plane polarized. One of the rays obeys, this is most important, one of the rays means this ray, suppose I'll take it, obeys ordinary laws of refraction. Ordinary laws of refraction means Snell's law, suppose say, okay, or okay, Snell's law. It obeys Snell's law and has vibrations perpendicular to the principal section. They are perpendicular to principal section. What is principal section? We define it soon. Okay. What is the principal section? We define it soon. It is called as, okay, there is a name for it. We will see. So a double refracting crystals, the incident ray splits into two refracting rays. One of the ray does not obey the ordinary laws of refraction like Snell's and has vibrations perpendicular to the principal section. This is so a dot means towards you, that is perpendicular direction, and this ray is called as ordinary ray. We call it as ordinary ray. Ordinary ray. And generally this is represented by O, ordinary ray. O ray we call it as. So therefore, out of two doubly refracting rays, one ray is O ray. Then the other ray. So what is the other law? It will follow this law. As vibration they are there. Within vibrations parallel to.
Sir, your voice is not clear, sir.
Parallel to, not clear. Okay, 1 second. Okay. The other
Can you start
way
recording?
ray does not follow the. Can you hear me? Am I audible now? Yeah, is it okay? Can you hear me?
Yes, sir.
Yes, sir. Can you start the recording?
I have already started. No? One a minute.
You have already started, sir.
Yeah, already. Just a minute. Yeah, can you hear me now? Yeah.
Yes, sir.
Still, there is some kind of network issue, sir, from your side, I guess.
Just a minute. Yeah, now can you hear me properly? Just a minute. I just
Yes, sir.
reshare the screen. Is it okay?
Yes, sir.
So now, if you look at this one, a plane polarized light.
Sir, we
In
are
this
unable
case,
to see your
the
share
other ray is not having.
We can't see your screen, sir.
Is it coming now?
Yes.
No?
Yes, sir. Yes, sir.
Yep. Yeah, can you see this now?
Yes. Sir, once can you tell the what is ordinary there? Like which ray
That's
is
fine.
that? Which are?
Can you hear me now?
Yes. Sir, you muted yourself, sir. Sir, we can't hear you.
Yeah, can you hear me now?
Yes.
Yes, sir. Yeah, can you see the shared screen and hear my voice?
Yes, sir.
Yeah. Now, if you look at this, ordinary ray. The second ray I'm talking about. The second ray will have vibrations. Just a minute. Yeah. The other ray out of the second does not follow the laws of refraction like Snell's law and has vibration parallel to the principal section. We call it as, what is principal section? We will define it by drawing a diagram soon. Okay, so we will write it as a principal section. And because it is not following the ordinary laws of refraction, okay, it's not following ordinary laws of refraction, and also having vibrations in the plane of principal section itself is showing some extraordinary property. Ordinary properties, it has to follow all the rules, but it is not following. That's why it is showing an extraordinary properties. That's why the other ray does not follow the laws of refraction and has vibrations parallel to the principal section is called as extraordinary ray. We call it as extraordinary ray. Extraordinary ray. And that's why this ray is generally shown as E ray. We call it as E ray. So we have two rays. Why we are getting this phenomena of showing two different rays? This phenomena, okay, is called, we call it as double refraction. So double refraction is capable of producing two plane polarized lights which are having vibrations in perpendicular directions, called double refraction. And the crystals that are showing crystals showing this double refraction so this phenomena we call it as double diffraction, and the crystals that are showing this property, okay, crystals showing this property, we call them as doubly refracting crystals. Property are called doubly refracting crystals. So therefore, we can produce a polarized light doubly refracting crystals. We can produce a, a polarized light from an unpolarized light when the light incident on doubly refracting crystals. And they produce an ordinary ray, O ray and E ray. This O ray and E ray, when you take it, they are O ray is obeying the ordinary laws of refraction, whereas E ray does not obey. And O ray will have vibrations in the perpendicular plane to the principal section, and E ray will have a vibrations parallel to the principal section. And examples of doubly refracting crystals, some examples of doubly refracting crystals, calcite is a one important crystal. Quartz is also a doubly refracting crystal. Topaz is also a doubly refracting crystal. And there are many such crystals which are showing this type of ones. And even if you take aragonite, aragonite is also another crystal. So tourmaline is also a doubly refracting crystal which shows the such properties. So we mostly concentrate on calcite and quartz here in our thing. So therefore, a double diffraction is simply the spreading of incident unpolarized light into two plane polarized lights. And these two plane polarizers will have vibrations parallel to the principal section or perpendicular to the principal section. The ray that obeys ordinary laws is called O ray. The ray that does not obey is called extraordinary ray, E ray. So we have O rays and E rays. And we have some differences between O ray and E ray. So I write some differences between O ray and E ray, and then we'll solve some problems. Differences between okay, O ray and E ray. So few differences and also few same behavior also shown by these two rays. Okay, so we will now write the differences between O ray and E ray. So I take here O ray and we will compare these properties with okay. Uh, so I take it here and I write with okay. We will write here E ray. What are the differences between O ray and E ray? The first difference what I'm taking here is that first O ray obeys ordinary laws of refraction. Okay, refraction. And for E ray does not obey ordinary laws of does not obey ordinary laws of refraction. This is common what we have seen in the earlier. And second point also we have seen the directions of vibrations. The second point is that the vibrations okay are perpendicular to principal section. But still we have not defined what is the principal section. We will do it in the next class. Perpendicular vibrations perpendicular to the principal section. Principal section is a plane, okay, containing optic axis. Of course, it's a plane containing optic axis and perpendicular to the faces of the crystal. So this is sorry, this is 1 and this is 2. 2 is vibrations of E vector of E ray. Okay, vibrations are parallel to the principal section. Okay, so sorry, I'll write here parallel to principal section. So perpendicular to principal section here, it is parallel to principal section. Principal section. These two you know it already. And apart from that, we have some important differences between these two. That is vibrations, differences between O ray and E ray. So I write here third point. Third important point is that O ray, okay, and E ray, if you compare them, in some crystals O ray moves faster than E ray. In some crystals E ray moves faster than O ray. Therefore, there are some differences between these rays. So therefore, I have to add up some more important points of O ray and E ray. Some other points is that, okay, important point is that along optic axis, we have drawn optic axis while discussing polarizing polarizer analyzer, but still we define again what actually optic axis is in a given crystal. A long optic axis, okay, the both the rays travel with the same velocity, same velocity. So the third point is same. Both will travel. That means along the optic axis, they don't show the difference. So both rays along optic axis, their velocity is same. But in other directions, E ray velocity is different, O ray velocity is different. Both rays along optic axis, okay, travel with same velocity, travel with the same velocity. That means velocity of E ray and O ray is same along optic axis, but in other directions, okay, uh, we'll extend and we'll say it. So what are the other important differences? The other important differences, if you know that these crystals are again divided into two classes as positive crystals and negative crystals. Therefore, we will
But
also see
there is the
what is
same point,
positive
sir.
crystal and what is negative crystal soon.
Sir,
Yeah. Yeah.
in
Can you hear me?
differences, you wrote a similarity, sir.
Yeah, this is only similarity. Okay, that's why we say that initially I told you that we have some same properties and other different properties also. This is similarity, of course. Okay, but that's why we even both will travel with the same velocity. Next, I will see the other differences which we have not so far seen, and therefore I'll write the fourth one, which is say that the since okay the ore travels in all directions with same velocity, with the same velocity, means that same velocity means that if I E ray is traveling in the same direction, in the direction with same. Therefore, I take the law.
Sir, your voice is not clear, sir.
Okay. Yeah. Am I audible now? So therefore, okay. Yeah, now can you hear me? Am I audible? Am I audible?
Yes, yes, sir.
Yeah. The O ray travels in all directions within the crystal with same velocity. Therefore, if you take locus of all these points, it covers same distance in same time. Therefore, we say that okay, in three-dimensional the crystal is three-dimensional. Therefore, in three dimension, it covers same distance in all three directions. Hence, the wavefront of O ray should be spherical. Okay. So therefore, we rate. Therefore, we say. Therefore, wavefront of O ray is spherical. spherical wavefront. But in case of this ray, okay, E ray travels with different velocities, with different velocity in different directions, travels with different velocities in, that's what anisotropic property actually, travels with different velocities in different directions. This is within the crystal, within the crystal. So because the doubly refracting media is important, within that media only we'll get all these changes. So travels with different velocities in different directions within the crystal. That means in this direction, if it's going faster, maybe in this going slow, maybe opposite direction. It may be going in the opposite direction same, but this may be different. So therefore, if I connect all this, I'll get an ellipse. So therefore, the wavefront of E ray is a ellipsoidal. Therefore, E ray wavefront, okay, E ray wavefront is ellipsoidal. We say E ray wavefront is ellipsoidal. It is an ellipse. Ellipsoidal means which starts rotating. That is what we say, it is ellipsoidal. We call it as ellipsoidal. So therefore, okay, we have certain differences between these two, but still I have some more differences to tell. But those differences we'll see in the next class, while in this class, okay, we will solve some problems. Okay, we will see some problems from the previous discussion. So we'll see problems here. Okay, so problems we'll say it on Malus law, etc. Malus law, etc. And Brewster law, that's we'll say it. Okay, so now we will look at this problems. Problems on polarization, Malus law. So first one, so look at the first problem. The first problem is based on the Malus law or Brewster law. So I'm writing here the first problem. The first problem is, okay, what is asking is a glass plate is used as a polarizer. You know that glass plate can be used as a polarizer by reflection. So reflected light is partially polarized. If you change the angle of incidence at a particular angle, it becomes completely polarized light. So a glass plate is as a polarizer. Okay. If refractive index refractive index of the glass is 1.54. Okay, calculate angle of polarization, angle of polarization, and angle of refraction, angle of refraction. So the solution is very simple. As we have seen, Brewster's law, which states that Brewster's law mu is equal to tan p. Here mu is given okay as 1.54. So is equal to tan p. Otherwise I'll write p the angle of polarization. So what we call it as angle of polarization is P is equal to tan inverse 1.54. Now, how much do I get? P
57 degrees.
57 degrees. That's all. 57 degrees is this one. And they are asking also angle of refraction. So angle of refraction also they're asking. So we have seen that at
33.
P, okay, R plus P must be 90 degrees because, okay, when you have the angle of incidence P, that means we'll get fully polarized light. At that point, R plus P is equal to 90. Therefore, R is equal to 90 minus 57. That is P what we have got. So R must be equal to how much?
33.
33 degrees. 33 degrees. You know it already. Okay. Next, the second problem is that they're asking that two polarizers, two polarizers, okay, have their polarizing directions, polarizing directions parallel to each other, parallel to each other. Means that the theta between them is 0 degrees, each other. Okay. That means when they are each other means the transmitted light is maximum. Each other you can write so that transmitted light is maximum. Transmitted light intensity light intensity is maximum. What they're asking is that through what angle, through what angle must either of either sheet, here sheet means polarizer, polarizer is a sheet, we call it as a sheet, we call it as a sheet, polarizer is a sheet. So through what angle must either sheet means here polarizer or other works as an analyzer sheet to be rotated, to be rotated so that the intensity becomes half of the initial value, half of the initial value, initial value.
So is it 45 degrees?
Yeah,
Yes.
only 45 degrees. Okay, we'll see how much it is. Okay, so that means initially there are two polarizers. One polarizer is here. This is the optic axis. The next polarizer we call it as analyzer. Actually, it because it analyzes the value, the incident light, this is 1. So theta is equal to 0. And now they want to show that either this or this, any one can be rotated. So if I keep this as it is, I am not rotating this. So I have to rotate this by some angle. Okay. If I rotate this by some angle, this is the some angle, this is the incident light, some angle, so that if this is the I is the incident light, okay, I here I naught, I call it as, the transmitted light is I theta should become, okay, I naught by 2, or I is equal to, sorry, I is equal to I naught by 2 is giving. So therefore, at what theta I should turn this. So we have Malus law which states that I equal to I naught cos square theta. And they are asking to find out what theta. But I should become I naught by 2, half of it. They are saying, so integer becomes half of the initial value. So this will use this theta, okay, this theta, how much it should be. So this theta should become I naught by 2. So therefore I'm writing is equal to I naught cos square theta. So I'll get cos square theta is equal to 1 by 2, or cos theta is equal to 1 by, okay, root 2. So how much, what is the, you said? What is the angle theta?
45 degrees.
But it's cos square, I'll get plus or minus. Therefore, I'll get 45 degrees. I can turn it. Otherwise, okay, if you turn 90 degrees and then 35 degrees, it may be 135 degrees also. So not just 45 degrees. You can turn 45 degrees also, 135 degrees also. So theta value will be 45 degrees either side plus or minus, or 135 degrees plus or minus. So we have the values. That is the theory value. Okay. The next problem is, it's a simple one. You can do by yourself very simply. The third problem is that the polarizing angle, the polarizing angle, or angle of polarization, we say, angle for a given material is 60 degree. Okay. Find the refractive index and a critical angle. Find the refractive index of the medium and critical angle. Okay. So you know mu is equal to tan p from Brewster's law. So mu is equal to tan of 60 degrees. So how much do I get? Anyone?
Root 3.
Root 3, correct. Root 3. So what is the root 3 value? 1 point?
732.
Yeah, 732, correct. Okay. Now they're asking to find out critical angle also. So to find critical angle, we have mu is equal to 1 by sine theta c, where theta c is the critical angle. You have this. So therefore, I can find out sine theta c as a critical angle as 1 by root 3. Because is root 3. Or theta c is equal to sine inverse of 1 by root 3. So how much do you get? What is the angle?
35.26 degrees.
To 35.2, 34.2,
35.26.
26 degrees. Okay, this is the way you have to find it. So I am writing the next problem. You just see it. The next problem is that he has given that two Polaroids are in crossed position. Two Polaroids, what I did, Polaroid or polarizers, right? Polarides are nothing but polarizers. You use Polaroid cameras, Polaroid goggles. Okay, two polarizers are in crossed position. Crossed means they are at 90 degrees. Okay, crossed position. One of them now, one of is them is rotated. We are rotated through 30 degrees. 30 degrees. They are calling what is the calculate. They are asking calculate percentage of incident unpolarized light, okay, that means they want a percentage for unpolarized light and the polarized light, of course. Okay, percentage of unpolarized light that will pass through the system, that will pass through the system, that will pass through the system. How much percentage it will pass? So it's also a simple problem. We have I equal to I naught cos square theta. Okay, this is the formula we had. Now we are saying that how much uh, they are in crossed position. Initially they are crossed position, means theta, they are saying that both of them are 90 degrees. Now the one of them is turned, that means here is the first one. Okay, this is in this direction, the other is at 90 degrees, something like this is the direction. So this is 90 degrees. One of them is turned 30 degrees from here. That means initially the angle between them is 90. Then it is turned 30 degrees. So I have to subtract 30 degrees. I'll get a new position, that is 60 degrees. Okay. So the angle between them is this. Otherwise, initially, if they say the two polarizers are parallel, means initially 0 degrees. From 0 they might have turned 30 degrees in the earlier problem, but here they are in crossed position. Crossed position means that they are 90 degrees. So we have crossed position. So crossed position gives you theta as 90 degrees. So therefore here, okay, theta angle between them is now 60 degrees. So I'll get I equal to I naught, okay, and it is passing through this. That means first part become half of it. So therefore I write this I dash is equal to I naught by 2 cos square 60 degrees. Remember and find the change also here what I am writing. They are in crossed position. When they are crossed position, some light is moving, but they have turned. Therefore, intensity for the first nickel to second nickel becomes half of it. That's why I have taken this. I naught, okay, I dash, new value, I dash is equal to this. So therefore, I'll get
Sir,
here, it is I naught by 2
sir, I didn't
cos
get.
60.
Sir,
How much do I get? Cos, huh?
I didn't get you, sir. Why did you take I naught by 2?
Yeah, see, our is I equal to I naught cos square theta is modulus law. Followed? Did you follow this law?
Yes.
From
Yes.
this, yes, now they are in the initially crossed position. They're in crossed position. So they want to find this intensity ratio. That intensity I don't know. I am writing as I dash. So I dash I want to calculate. But what is I dash? I dash is that if I take initially the first Nicol prism or first analyzer, the light that is coming, I have to see it. To see that first, I say this is some angle A, and I have here A cos theta, and I write this as A sin theta. So therefore, whatever the intensity that is there, okay, if the angle I have turned is this, okay, 90 degrees, that means each of them will make 45 degrees. Then what is cos 45?
Yes, sir. I got it. 1 by 2. Then it is cos square 45 1 by 2.
Yes,
1 by
1 by
root 2.
1. Square is, yes, because this is
1 by
intensity, yeah, 1 by 2. This become I 1 by 2. And I'll get cos square 60. So how much do I get? Value? I dash value.
I naught by 8.
I naught by 8, correct. Okay, but he is asking to find out the unpolarized light. Unpolarized light is I naught, and by after turning 30 degrees, that is I dash, whatever you are writing I dash. So this will be, okay, percentage is asking, so you should multiply by 100. So I'll get, okay, I naught is 100%, initial one. This is whatever that is incident is, we take as 100% into this by, okay, this. All right. So I will write, otherwise I'll take this. So therefore, I will write this as 1 by 8, because I naught, if I say this is I naught by I dash is I naught by 8. Yes, is it that? Is if asking to find out the ratio of unpolarized light that pass through the system, that pass through the system. He is asking, not the ratio of that pass is only I dash. So therefore, sorry, I'm just rubbing it off. I'm writing it as the problem they asked as the incident unpolarized that will pass through system is after coming how much? After coming how much is nothing but I dash. I dash is coming out. Okay, so therefore I should write I dash is coming out, initially this is I naught, therefore I have to write into 100, I should write to get the percentage is equal to I dash is I naught by 8 by I naught. So I will write 1 by 8 into 100, so into 100%. Did you follow this? See the problem. Problem is how much light has passed percentage. So that's why I am getting the how much light is this transferred. So how much do I get? Maybe 12.5%.
Yes, sir.
Yes, sir.
Yeah, 12.5. So therefore, this is the way in which you can calculate. And I'm giving you the last problem. I'm stopping here the class, but you do the problem and tell me the answer later in the next class. The as a homework I'm giving here, next problem I'm writing. Okay. So the next problem is you have to calculate this as a homework. Okay. The problem given is calculate Brewster angle. Calculate Brewster's angle, that is nothing but P, angle of polarization. Okay. For the liquids, A, ethyl alcohol, ethyl alcohol. Okay. Of course, ethyl alcohol have a refractive index 1.361 is the refractive index of it. B, carbon tetrachloride, for which mu is equal to 1.461. Okay, you have to find and also find angle of refraction. Angle of refraction. Okay, so you do it as homework and give me the answers tomorrow. So